So making solutions. Today we'll make a solution, a 0.5 molar solution of copper sulfate, and we'll show you how to do that today. What you need is some DI water, a volumetric flask with the amount that you're going to make. So we're going to make 250 mils today, and some copper sulfate, a balance, and you're good to go. So we're going to use the volumetric flask for our final volume because it's actually way more precise than a beaker. A beaker's the graduations are not as precise as the single graduation on the neck of a volumetric flask. So to start off, because the neck is so small, it's difficult to transfer solids into the volumetric flask. So I'll go ahead and weigh into a separate beaker, dissolve this up in a little bit of DI water, and then you can transfer it easily with a funnel. So first off, I'll start with this beaker on the analytical balance, and I'll go ahead and tear the beaker, and then I can take it out, add solute, and get the desired or the calculated amount of solutes that I need for the half molar solution. Yeah, that's good. So once you've weighed everything out and you get really close to your final mass that you need for your solution, just go ahead and keep the beaker inside, and you can just make smaller transfers and hit the desired mass. It's good to tap the spatula a little bit so you don't have to pour everything out. You can just sort of tap it in a little bit at a time, as best as you can. Okay, so once you've weighed the appropriate amount on the balance in the beaker, we can add some DI water to the beaker, dissolve it up so that we can easily transfer with a funnel into the volumetric flask. Now the only thing you got to worry about is don't add too much water. It's really not possible since it's only a 100 ml beaker. This is a 250 ml volumetric flask. Just something to remember in the future if you got a bigger beaker. But yeah, just go ahead and dissolve up some DI water. I have a stir bar right here that I can add to it. Get it stirring. So our solution's been stirring, it's all dissolved now. We can go ahead and move on and transfer it into our volumetric flask. So I'll go ahead and stop the stirring. Funnel there. So when you're getting your stir bar retriever and you're going to go ahead and dip it in, get your stir bar, you want to make sure that you rinse everything off with the solvent that you're using so as not to lose any of your product. In this case it's water. So I'm just rinsing with a little bit of deionized water. Go ahead and take that out. And now we can safely transfer without the stir bar falling in it. So now we'll go ahead and it's all in there. So remember, we want to quantitatively transfer, so I'll go ahead and rinse the sides off. My best to get every little bit. Do that a few more times. Okay, so we quantitatively transferred from the beaker. Now last thing we want to do is pour using a funnel, so make sure you rinse off the funnel as well, so you can get the product that was stuck to the funnel. Now, we can go ahead and bring the water level back up. So we have every bit of the copper sulfate that we need in here, and now we can bring it up to the graduation on the volumetric flask. And you can also keep using your funnel to get your water in. Just be careful when you're using the funnel, because sometimes you can get a little too ambitious with your pouring. Okay, so you notice it's getting really close to the edge, or at least we're getting really close to this line. Now I don't trust myself to pour a large glass as exact as I need it, so I'll just go ahead and get the pipette and pipette the remainder in there to try and get the bottom of the meniscus right on that line. And that's what happened.
Here we go, whenever you want.
Okay, so now that we have the correct volume, we can go ahead and stopper the volumetric flask, and we want to mix this up. So you want to keep, when you try and use two hands, keep the stopper closed with one hand and invert with the other, and just do this a few times. Just trying to get everything nice and homogenized. Okay, so now we want to transfer this into a storage container. Here we have a 500 milliliter Nalgene bottle, and we just pour straight into it. Okay, so you'll notice that when we were transferring from the volumetric flask into our Nalgene storage bottle, we didn't quantitatively transfer. And the reason that is because we have a specific molarity of solution of copper sulfate that we wanted to maintain. And if we were to quantitatively transfer, we're adding more solvent or adding more water, in this case, to the solution, and it throws off the molarity. So we just poured it all out into here, and we may lose a little bit of the solution itself on the sides, but that's okay because we didn't contaminate the molarity of this solution. Okay, so now once everything's in the bottle, the last thing to do is to make sure you label it with your name, date, and what it is. So I'll go ahead and put my initials on there. Date. And then molar. Copper sulfate solution. So we have my initials, the date, the molarity, and a copper sulfate solution. Alright, so let's say you have to do a basic wash as part of your aqueous workup for a reaction that you just ran. Well, in this case, you would use a stock solution of sodium hydroxide, and because it's just a basic wash as part of the workup, we can be a little less precise and use this graduated cylinder to bring up the volume that we want, instead of the volumetric flask as we used in the last part. Also, we're going to be using a top-loading balance instead of the analytical balance, because to make a 5 molar solution, we need, we calculated out 100 grams of NaOH that we needed. For a larger mass, we're going to go ahead and use the top-loading balance. Again, it doesn't have to be as exact, so no need to use the analytical. So since we're weighing such a large amount, we can go ahead and tear the beaker onto the balance and weigh our NaOH into the beaker. That way, less mess, we can go ahead and get it dissolved and transfer it a little bit easier that way. So, put that there. Tear it out. And start weighing. Okay, so now that you have your NaOH all weighed out, we can go ahead and add some water, some DI water, into here and get it dissolved up, and then we'll transfer it into the graduated cylinder. Okay, a quick thing to note about the NaOH. When you're mixing it with water, it's actually a really exothermic mixture. You can even see here it's steaming up a bit, and it actually puts off a little heat caution on the stir plate. Normally, this is heating something else, and it'll read whether the surface is too hot or not. And it's not even heating, and the NaOH solution just turned it on. So we're just gonna let this wait a little bit. Just be careful. It's a lot of NaOH to put in water. Alright, so it's all done stirring. Everything's in solution, so we're good to go on bringing the volume back up to what we need. Now, first off, there's a stir bar still in there, so make sure you grab the stir bar and rinse it off with a little bit of your solvent. Yeah, we're just using water right now, so I'll rinse it off with water. Also, as a side note, be sure when you're working with pipette tips and the bulbs to not invert the setup right here, because whatever solvent that you have that's in the glass tip can go down into the rubber bulb and erode it actually, so don't invert the tips. So now, go ahead and pour this in here. You don't really need a funnel, the opening's pretty large. And since we're quantitatively transferring, I'm going to rinse some of the sides with this water. That once. And in quantitative transferring, I sort of like to think of it as when you're pouring milk out of a glass. If you've ever done that, you pour milk out of a glass, maybe into another glass. If you notice, the first glass that you poured out of has a lot of milk just like sticking around on the sides. Well, if you can imagine the milk as your product in a reaction, you don't want to lose that little bit that's on the sides because it could be a sizable amount. So you quantitatively transfer, which is just you rinse the sides off, you try to get that little bit of product out and pour it back in with the rest of it. So now we're here. We have every bit of NaOH we need. Now all we need to do is bring up the volume to the correct molarity. So right now we're at 250. We'll go ahead and bring that up to 500. So, you'll note earlier when I was trying to read where the water level was, I went eye level with the graduation and I looked to see where the meniscus was. So, polar things in glassware will form a meniscus because they will climb up on the sides and it will create a dip. And you want to read the bottom of the dip as your accuracy for level. So, if there's a bit of a meniscus here, it's kind of wide in this graduated cylinder, but you can see it. And if the bottom is at your line, then that's where you want to be. So from here, we can go ahead, we have the amount that we need, and this is a 500 milliliter Nalgene bottle just to store it in. And you can go ahead and pour it straight into here. Okay, so now that everything's in, the final and really important step that you have to do is to label your bottle. So I've already prepared a label. you just put it on the side right here. What it is you just have some sort of masking tape, and you can just get a little Sharpie, put your initials, the date, and what it is. So it's a 5.0 molar NaOH solution. So when a 5 molar solution is too much and you need a less concentrated solution, you can go ahead and make a 1 molar NaOH solution without the pellets. You can simply dilute a portion of the 5 molar NaOH and bring it up to a 1 molar NaOH of a certain volume. So I need 100 mils of a 1 molar NaOH solution, and I've done the calculation and I need 20 milliliters of a 5 molar solution. So I mean, you can do this a number of ways. You can get a graduated cylinder or maybe use a smaller beaker. But I have a syringe here, and I'm going to go ahead and bring this up to 20 mils and transfer it that way. Okay, so now we have all the NaOH that we need from the solution. All we need to do now is bring up the volume to 100 mils is what I need. So I'll just get some DI water, pour this up. We're at 100. And that's all there is to it. This is a 1 molar solution, 100 mils of it. So I'm going to go ahead and use this right now. Edit.